Welcome back, sixth graders, to lesson 72, and we are going to be on page 349. We're talking about exponents, writing decimal numbers as fractions, part 2. So what we're going to look at first is we're going to look at exponents, which means the definition of exponents is repeated multiplication. And we talked about that a little bit when we were talking about squared. So what we're going to look at first is how exponents are used. They kind of make things easier when you're multiplying, so you don't have to keep writing it out long term. But what we're doing is we're looking at, for example, on where it says compare 3/4 to 4/3. Well, let's lay the groundwork first. First off, we know that 3 squared, which we've learned earlier, right here, means the squared basically means how many 3's do I have. So in this case, 3 squared means I have 2 3's, which means the answer is 9. Piece of cake. We learned that earlier. Then we got to jump down. We're getting a little early. We're getting into a little more larger exponents. So for example, the first exponent we have is 3 to the 4th, comparing to 4 to the 3rd. Well, if we take a look at it, first off, the exponent that has a 3 has another name. It can be cubed. Cubed meaning 3. Okay, 3 measured. That's going to come back in when we start measuring three-dimensional figures later on in the book. Now, what we're going to look at right now is we're comparing. So we're basically saying which way are we going to have the arrow pointing or the mouth pointing towards the larger number, which we talked about earlier. So first off, we know 3 to the 4th. That tells me I have 4 3's. So I have 1, 2, 3, 4. And that's going to turn around as we're looking at, and that's going to equal for us 81. So we have a total of 81 for the first one. And it makes it a little easier. Like I said, you can basically do the math. 3 times 3 is 9, 3 times 3 is 9, 9 times 9, 81. Second one, then we're looking at the next one, which is 4 to the 3rd, which means we have 3 4's. All right, as we're looking at 3 4's, we can multiply that up, and we get 64. So when they're writing it up, the first thing you're going to want to do is you're going to want to prime factor out your numbers. And remember, prime factor means that itself and 1. Basically, that's what it has, only 2 factors, exactly 2 factors. Okay, so in this case, we have 81 greater than 64 when we've done the multiplication, so therefore the mouth is going to open up and we make our little teeth like we used to towards 3 to the 4th power. Okay, now it's solving with exponents. If I looked at this number, and I wanted to do this first because this is what we did when we were prime factoring out the numbers. If you recall, when we talked in class, we figured out how many 10's we had in 1,000. So the first thing we had was we counted up 3 zeros, so therefore we have 3 10's. So 10 times 10 times 10 is going to equal 1,000. And so therefore, to prime factor that out, what we did, if you recall earlier, we went 2 times 5, and we went 2 times 5, and we went 2 times 5. We had all the 10's because 2 times 5 is 10, 2 times 5 is 10, 2 times 5 is 10. They are all prime factored out. We have all 3 sets of 10's, which equals 1,000. So that way it becomes easier to solve. Each zero is the big thing you guys got to remember from what we said earlier. Each zero represents a factor of 2 and 5, which equals 10. Do that. It doesn't matter how big. If they throw a number out that is 100,000, we have 5 zeros, so we're going to have 5 cents of 2 and 5. So we go, if we had the 3 set there, we would keep going with an additional 2 more. And so again, each zero representing 2 times 5, a multiple that equals 10. All right, with that in mind, bouncing down, here's a little another solving equation. We have 100 subtracting 10 squared. Well, we know right away from previous experience with the squared, that equals 10 times 10. So we keep on carrying down. 100, 100, 100 all the way down. Subtract 10 times 10, which equals 100, which equals 0. Now, I know some of this is going to be it's very simple for many of you. It's okay if you don't get it. Again, please give me a jingle via the Teams chat deal, and I'll gladly walk you through any part of it. So again, this is just the exponent. Next, we're going to move over to the decimals. Okay, now, slight pause so we can move the podium to get us focused in on the next set. We have writing decimals as fractions. And I know we've already talked about and have did this, and some of you say, Mr. White, can we please get started? And I would, of course, probably tell you, yes, you can. If there's a little trick we need to make sure we're familiar with, we do that. But again, getting out of your way. If you feel you got a handle on it, get going, get it done. The assignment's on the worksheet that I will be texting out to you for the week's assignments. And you can work on any speed you want to work on. You are not restricted by me. If you want to do all 3 lessons in one day, do it. It's up to you, because right now it's going to be a light homework load. We want to keep things moving though, with the hope that we get to come back here towards the end of May, or end of April, excuse me. All right, so digressed a little bit, but here's where we're heading. Writing decimals of fraction. The biggest thing we need to remember is this first part right here. And that is, we have 1 decimal place to the right of the decimal, which if I had you read that, you would, but somebody in class would raise their hand, well, it's 5/10. Or you might even say 0.5. But remember, we're trying to focus on pronouncing it what it actually is, which means 5/10. All right, so tenths is the key word. 5/10, 1 decimal place over, so therefore I have a 10, which represents 1 decimal place. So every 0 that I put in represents a decimal place. So if I said 5/100, I have 2 decimal places, so that becomes 5 over 100. If I say let's do that again. If I say 5 thousandths, that's going to be basically, take the decimal back out, 5 over 1,000. Notice the pattern. 1 0, 1 decimal place. 2 zeros, 2 decimal places. 3 zeros, 3 decimal places. The pattern continues. No matter what. You can keep going. If I take, we'll go on another one. Then it's going to be, I have 1, 2, 3, 4. 1, 2, 3, and then 4. Okay? And I kind of got below my line here. This is my line to keep me above. So good job on adjusting, Cass. All right. Let's bounce over to change it into a mixed fraction here a little bit. And this is kind of what we said. We just talked about the places, 2 place values to the right of the decimal. Therefore, 3, which is to the left of the decimal, becomes our whole number. So we have a whole number here. And now we're back to just the fraction, which means we have, to the right of the decimal, we have 2 decimal places. Therefore, with the 2 decimal places, we're going to have 2 zeros. 75 goes on top, so our final answer for changing into a fraction portion is going to be 75 over 100. But that's not reduced. We can reduce it down. So with the reducing down, again, best friend, just like we did earlier in the lessons, prime factorization. Well, we know we're dealing with 5 and 0, which means a 25 is going to be in there for both of them. So if you notice, I have 5 times 5, which is 25, and 5 times 5 is 25. So now I have to ask myself, what times 25 equals 75? 3. What equals times 25 equals 100? 4. And then we prime factored out the 4. So every one of these numbers is a prime number. So therefore, I'm now ready to cancel out my 5s. I can take a 5 out of the top and bottom, which equals 1. 5 out of the top, 5 out of the bottom. What I'm left with is 3 on the top, which goes on the top here for my fraction, 4 on the bottom, which equals the 4. Final answer, 3 3/4. The whole number comes along for the ride. So your final answer is 3 3/4. So we changed 3 and 75/100ths. We counted the decimal places. 1, 2. 2 zeros, which gave us 75 over 100, which is where the fraction was. Then we prime factored it out to get to the 75 down to just the basic numbers of reducing that. And some of you still like to reduce it the regular way. That's fine. That's up to you. But again, prime factorization, using it and canceling out top and bottom, you can do that. And then your final answer, 3 3/4. So again, if you have questions on that, we can walk through that one-on-one through the chat deal. So that is lesson 72.